Hi guys, I am Parampreet Singh, and as you all know, I have been taking MLP sessions, and today we will be having our session 16, which is on three major machine learning algorithms. Those are KNN, first is K nearest neighbor, and then the second is support vector machines, and the third is naive bias. All right, and by the end of this session, we all will be like cleared with the week 7 and week 8 concepts. Yes, let's start. um, okay. Before starting, just want to share I'm recording this session and I will share the recording in my YouTube channel, which is this, so you guys can subscribe to it and keep the notifications on, so then you will get the notification whenever I upload this session. Okay, so let's start. Is my voice like loud enough? um okay, anyway,
Yes.
you guys can even it's better if you all interact, so मुझे थोड़ी आसानी होगी इनफैक्ट इससे. All right, so before this KNN, SVM and the naive bias, suppose like all of you are clear with the classification and types of classification problems, right? I'm assuming that if
Yeah.
anybody has any confusion, you can ask. Okay, so let's start. Just a moment. All right. Um, okay. So first we will start through KNN, that is K nearest neighbor algorithms. Then we will move forward to SVM, and hence at last we will cover the naive bias. um, naive bias is easy, well चाहे तो हम पहले भी cover कर सकते हैं, but the main understanding is more needed in KNN and SVM compared to naive bias, so इसलिए okay. Okay, so K okay, so K um, now, yeah, now it is better. KNN, that is K nearest neighbors. So can anybody tell me what this ML algorithm is about? Like, what is KNN algorithm? Anything?
Essentially, the prediction or the classification is
Mm-hmm.
done with respect to the labels associated with k number of nearest neighbors. So that distance can be Euclidean distance or some other.
Mm-hmm. Right. Uh, you were right. Like almost. आपने सभी बता दिया. Okay. So let's take a basic example. Let's first it is obviously it is under classification we are doing. So let's plot a graph. Okay. Here let's say we have two features, and in these two features I am like, okay, let me use different colors. Okay, so let's suppose we are working with a multi-class classification problem. Okay, with the 5 labels. All right, so sorry, not yeah, multi-class classification problem, and with the 5 different classes. So let me plot different classes. Okay, so let's suppose the class 1 is represented by red dots. All right, okay, so let me make it bigger. That will be much better. Yes. So these are some dots for the red class and some dots here for green class, some for blue class. I'm just highlighting in different colors. Okay, for blue I think same ही लग रहा है. Let me take this one. And then we have like, let's say, some orange as well. Okay, then last yellow both. Okay, I have plotted with various classes. Uh, now it is much better. You like all the different colors are visible, right? I think yellow is not that much visible. So let me change the yellow with some other color. Let's say this purple, not the dark, light one. All right. So is that graph clearly visible to you all? Um,
Yes.
okay.
Yes.
So like what a k nearest neighbor do is simply like हमारे पास different classes होती है, right? And in each different classes basically we have to classify each of the class, like we have to classify the samples that which sample belongs to which class. Okay, so there are many machine learning algorithms. One of them is k nearest neighbor. What this algorithm do is it simply like as a name suggests, it has some like k value. Okay, and it is a variable or hyperparameter in fact. Okay, which you can say. So k is like you are defining some kind of a centroid in the some kind of a point, and that point we call it as a centroid in the data, and based on their, it's like uh, neighbor samples and their classes, it chooses whether which class it should belong to, that different uh, like k nearest neighbor. Basically, that kth neighbor, kth centroid, with which class it should belong to. Okay, so okay, it's just mainly like, okay, let's suppose I have set k equals 1. Okay, so we will take each different scenario like for different k values. So let's suppose k equals to 1. Okay, so if I simply like, let's suppose मैंने एक centroid बना लिया यहाँ पे. Okay, and k equals to 1, so it simply take all the nearest neighbors, and how it will check the nearest neighbors, the basic intuition behind is it will calculate the distance between this centroid. Okay, this is the centroid. It will calculate the difference between the distance between the centroid and other samples. Okay, like this and these, like all the respective classes and all. Okay, from here and here, it will simply calculate the distance, and after calculating the distance, let's suppose it okay, 1 के लिए तो we don't have that much big example, like you can say any kind of uh, different classification we can say. So k equals to 1 means it will consider all the samples here which will belong to that centroid, this nearest neighbor. Okay, if we move on to like some more number of centroids, let's say k equals to 3. Let me take the example of k equals to 3. Okay, and how do we simply start these centroids? We can define them in like anywhere in the data set. Let's say one centroid is here, one centroid is here, and one centroid is here. Okay, Now how it works, let's take the first centroid at first. Okay, so it has this nearest class. Let's suppose these three nearest class, and these this one, and okay, and let's suppose this one as well. Okay, not this one, this class. Okay, so these are the various classes this centroid is like it has uh, in some, you can say, a radius, or let's suppose some particular threshold level. Okay, and उस distance के बीच में like in that particular area, the जो भी हमारे पास different classes आ रही हैं, हर एक class का like it will do the simple majority counting. Like the centroid is belong to the respective class which has the majority number of like that respective class samples. Okay, uh, near to it. So let's suppose for the orange one, it has, okay, let me zoom out. Yeah, for the orange one it has three classes, right? Three samples. And for the blue it has only one sample. For the green it has two samples. Okay, so what it will do is it will simply like consider this orange class because it has the majority number of, this centroid has the majority number of uh, orange samples, okay, compared to the other ones. So hence it will simply consider that neighbor belongs to this orange class. And now what it do is it simply like all the neighbors which are near to this centroid, okay, this specific centroid, it will be considered under this class. Okay, let's suppose this is the radius it has, so all these samples will consider as the orange class. Okay, this is for this specific centroid. Now we will look into the second centroid. So it has like this this centroid is already covered up, so we won't take this one. And it like it has two green labels closer to it, and so many like you we can say so many red labels closer to it. Okay, so here if we calculate the distance of this one, this centroid, uh, okay, so it will be like a green color. Let's suppose for the second centroid it has three samples, and for the red class it has let's say six samples. Okay, then it will consider all the its nearest samples as like of belonging to the red class. All right, and then for the last, let's suppose this centroid is here, it is like taking these two classes and a lot of purple classes. Okay, so then it will consider this third centroid, it belongs to the this purple class, and all other centroid, sorry, all other samples which are its neighbors comes under this class, and it classifies it as a purple. Okay, so this is how mainly a k nearest neighbor works. Okay, so itna sabko clear hai? This is like not much, it is basically checking the neighbors and finding the majority vote count. Okay, so is this much clear? All right, बाकी सबको clear है? कुणाल, निवेदिता, all right. This is the basic intuition behind this k nearest neighbors algorithm. इसमें कुछ ज़्यादा नहीं है, it is very basic, and um, mainly like we don't need to simply, हम इसको train नहीं करते. Like what do I mean by that is okay. Yes, so what do I mean by that is we simply compute the distances like its respective neighbors and their respective classes, and हम बस उसको assign कर देते हैं. That is, you can say, the training part of this k nearest neighbor. And then let's suppose मेरे पास कोई एक test sample आता है. So how should I denote a test sample? Okay, let me take the test sample via this white color only. Okay, so let's suppose I got some test sample here, x, you can say xt. Okay, and that is somewhere around here. Okay, and with the respective x2 as well. Okay, so then it will belong to which class? Like this test sample, like okay, its nearest neighbor is which one? this red or purple or orange, like if you see the boundaries, in under which boundary it is coming, the red one, purple or orange one. You guys can even speak or in fact write as well. All right. So see, मैंने क्या किया, एक टेस्ट सैंपल प्लॉट किया, yes, and वो टेस्ट सैंपल when I plotted it, you can see it is coming inside the orange boundary. Okay, so it will be considered as this closest, like the nearest to this respective neighbor, and hence it will be considered as like it is under the like it is considered as the orange label. Okay, orange class. So इसका जो prediction आएगी, that will be like for the same number which is for the respective orange class we have. Okay, so this is how the testing is being done in the k nearest neighbor. So बहुत ही बेसिक सा एल्गोरिदम है, ज़्यादा कुछ है नहीं. The main thing is like behind this is like finding the optimal values of k. Okay, also like there are various distance metrics as well, like which one should we choose. Okay, so the main thing is that uh, abhi tak this much is clear, like how testing is being done and other things. Okay, so now basically simply finding the optimal values of k. Let me like, okay, if I simply select this one and let me copy paste it here, and let me erase some of these values. um all right, now it's better. uh, just a second. Okay, so like let's suppose the main task is to find the optimal value for k in the k nearest neighbor. Okay, so let's suppose if I have set k equals to 1 and वो centroid मैंने कहीं यहाँ define कर दिया. Okay, so whatever, let's suppose okay, not here, let's take the green one right now. Okay, so I have defined the centroid here and it has like majority number of green samples around it. Okay, so and imagine it has a like its boundary something like this. Okay, so whatever like samples, like doesn't matter whichever test sample I add on, okay, inside this, it will be considered as a green label. Okay, it will be classified as a green. Okay, so that is simply, you can say, the case of overfitting. Like सबका ही जो है overfitting means like it is completely like overfitted to the training data, and अगर हम कोई भी टेस्ट सैंपल डाल रहे हैं, so उसका आंसर भी हमें सेम ही मिल रहा है, like we are getting the green and green again, doesn't matter where our test sample stands. Okay, so obviously using a very low value for k should be an integer, not an integer, a natural number mainly, and a very low value of k will leads to overfitting, because एक ही class के लिए वो identify कर पाएगा, not for respective a lot of classes. And now k equals to 3 का तो मैंने आपको example दे दिया, and here the k equals to 5 fits better, like based upon the samples we have. And let's suppose मेरे जो है जो centroids हैं, these are defined something like this. Okay, so they will have their respective you can say boundaries and all. Okay, so it is having the background. Okay, let me remove the background. So let's suppose this centroid has this class and this has this, and for the red one it has this kind of decision boundary, and for the purple it has this, and hence for the orange it has these. So these are, you can say, the decision boundaries, or under which all the samples are coming. Now okay, इसमें yeah, yes, okay. So what happens is, let's suppose कभी कभी क्या होता है, some values, like if we set some k value to a higher value, अभी तो मैंने like I have defined only the 5 nearest neighbors. तो अगर मैं इस पे okay 7 भी अगर मैं neighbors define कर लेता, okay, so this will be, you can say, an optimal value for k, like based upon the training labels we have. Okay, so but let's suppose if I define various number of centroids or the k nearest neighbors, let's suppose I have k equals okay, in the 5 in fact मेरे पास एक case आ सकता है something like that, like these. Okay, so green like all these will be classified under this centroid, and all these will be classified as this, and all these will be classified under this, and all these will be classified under this. And कुछ केस में ऐसा हो सकता है, let's suppose this centroid, or let me take this centroid to rather this, हम ना randomly we define the centroids, or we can in fact set its like specific position as well, like कहाँ पे होना चाहिए define. Let's suppose मैंने यहाँ पे define कर दिया and it does not like इसके रिलेटिव कोई भी हमारे पास क्लास नहीं आ रही, so that may lead to our kind of, you can say, अंडर फिटिंग कंसेप्ट, क्योंकि हमारे सारे सैम्पल्स भी कवर अप नहीं हो रहे एंड वी हैव सम k value that is centroid that is not belonging to any of the classes. Okay, so एक केस ये भी होता है, and sometimes we have like, let's suppose अगर मैंने k की वैल्यू बहुत बड़ी रख दी, then we will have various centroids, something like here, here, here and here. So ऐसे बहुत सारी क्लासेस हो जाती है, एंड लेट सपोज इसकी डिसीजन बाउंड्री कुछ यहाँ आ रही है, मैं बाकी सबकी डिसीजन बाउंड्री नहीं बना रहा, एंड इसकी डिसीजन बाउंड्री कुछ ऐसे यहाँ ऐसे आ रही है. ओके, नॉट कोलाइडिंग मेनली, like something like this. Okay, so this may lead to underfitting, like because it is like identifying the same samples under two different, you can say, the centroids, and this will lead basically इसमें हम correct prediction हम नहीं ले सकते, like if I point a sample here, something like this, we say this comes under the red class, and it also has like this centroid also has like in this decision boundary, uh also we have the, let's suppose, majority red classes here. Okay, so it won't capture this green one here, and it will only capture the red one here. So red ke liye we have more number of k values or more number of centroids. Okay, so it is kind of it leads to underfitting. Like underfitting means एक के लिए you can say for some respective classes we have various decision various k value these centroids, but for some classes we don't have any. So ऐसा case तब आता है like when we have some higher k value, and that higher k value is generally like let's suppose obviously classification maybe, and in regression also it works, but in a different way, we can say. Like if I normally give you a uh, like एक छोटा सा अगर मैं आपको एक एग्जांपल दूँ, it will be like अगर हमारे पास n equals to 10, अगर हमारे पास 10 फीचर्स हैं एंड 3 क्लासेस हैं. ओके, सो इट विल बी बेटर कि हमारा जो हमारी k की वैल्यू है, इट शुड बी अंडर दीज वैल्यूज. ओके, सो उससे जो है हमारा k की वैल्यू ऑप्टिमल रहती है, एंड वी विल गेट द बेटर मॉडल जो बेटर आइडेंटिफाई कर सकता है सैम्पल्स को. ओके, सो लेट सपोज अगर मेरे यहाँ पे एक सैम्पल आता है, इट शुड कम अंडर द ग्रीन वन, but due to this centroid it is considered as a red label. Okay, so it will be like it is misclassifying it, and hence it is a kind of a concept, so hence it is underfitting. Okay, so it leads to the concept of underfitting, and I know थोड़ा underfitting and overfitting का लग रहा होगा mainly. Okay, अभी like जितना मैंने like this under overfitting and underfitting का clear, like don't go into the terms cheaply, overfitting and underfitting, mainly इतना clear like that a very less value of k is not suitable, as well as a very high value of k is not suitable for our model. This much, like, mainly I wanted to explain this much thing. So is this clear to you all? बहुत ही बेसिक सी चीज़ है. Mainly इसमें और कुछ ज़्यादा है नहीं. And apart from that, the thing is, like, we have various kinds of distance metrics. Like, we have Euclidean distance, right? Euclidean distance, we have Manhattan distance and various distance classes. So जो हम nearest neighbors जो हम capture करते हैं, let's suppose this for this class, if we, I'm just taking a sample random example, okay? Don't go into the formula and actual value. So let's suppose अगर मैंने यूक्लिडियन डिस्टेंस की हेल्प से आइडेंटिफाई करना चाहा, तो मेरे पास कुछ ऐसे ये एज अ सैम्पल्स आए, ओके, for this respective centroid. And let's suppose if I try to use the Manhattan distance, so I get these kind of the samples, okay? So based upon the distance matrix, हमारे थोड़ा सा neighbors different labels को classify consider कर सकते हैं for their respective labels, and उसकी वजह से भी we may get a different model, and that model may be worse, that model may be better. That is up to the you can say the you can only judge by the evaluating the model based upon validation or test set, okay? So the main two things in the k nearest neighbor is the handling the best value of k, finding the best value of k, and setting up a good a good distance metric, okay? So the main thing is this. Now let me show you a very simple code example. कोड में तो वेल आप लोगों को पता ही होगा, ज़्यादा कुछ नहीं. And let me take the Titanic data set one directly. Okay, kaggle.com competitions Titanic, and if I copy it, and I'm just adding it here. So okay, it is saying adding source. Okay, so the data set is added. Now if I run it, you can see I have the data set here. Now I'll simply load the data set, pd dot read underscore csv, this df dot head. I'll simply drop all the nan values, okay? Df dot drop na in place true, and I will only consider the numerical columns, okay? So for the sake of not doing any kind of pre-processing and all, fluid equals object dot not columns, yeah. So that will be my the final df. Now if I check my data frame, okay, sorry, it is in place. Yes, now we have this passenger id ko, let me set it as the index column as usual. All right, so we have these columns, and we have the survived class, which is which should be the which is the target label, okay? So I'll simply set this x and y, df dot drop, and after, okay, columns equals survived, and y equals df survived, right? So I'll get my these x and y values. Now I'll import the k nearest neighbor classifier. So from sklearn dot neighbors, okay, yeah, neighbors, import k nearest k neighbors classifier. K neighbors classifier is simply for classification stuff. And similarly we have the regressor as well. Regressor may mainly you can say mean is being computed, okay, rather than the various distances and classes के लिए we have a centroid, but mainly like we use the classifier only because this model is majorly mainly made for the classification stuff, not for the regression. So K neighbors classifier, and here you can see I have the default value of 5. And okay, then there are some weights also, like we can set various weights, or we can set uniform or some random weights as well. And then we have the metric. That metric specifies the distance metric which should we use. Like default is, you can say it is min cos okay, min cos v. And then we have like some other metrics as well. We can check the metrics from this library. Okay, we will look into that later. So we will simply do is fit the model. Let's say okay, let me split the dataset as well. From sklearn dot linear model, okay, not linear model, model selection, import train test split, and I'll simply split the dataset x valid, y train, y valid, train test split, xy, test size as 0.2, random set let me set as 0. Okay, then I'll fit my training dataset here, y train, and I got my classifier. And if I check the score, so by default it will return the accuracy because it is a classifier. So if I pass x valid and y valid, you can see I'm getting an accuracy of 0.75. Okay, with the k equals to 5. If I set k equals to 3, here, okay, not k, it is the n underscore neighbors parameter. You can see with the k nearest neighbor 3, it is like it is having a very low accuracy. That you can say like, okay, मैं 1 के केस से start करता हूँ. Okay, uh, let me do, okay, model dot predict as well. If I do this model dot predict and it's valid, I'll take first 10 samples only. And okay, so not the one, let's take the 2 value after that. Yeah, so you can see like for the n neighbors 2, that is the 2 neighbors, we are getting the 54 accuracy. Like you all might think कि हमारे survived class में तो we have only have 2 survive on the target label, we have only 2 classes, that is either 1 or 0. Still we are getting this like 54 accuracy. Why? That is because of the case, let's say if I have let me plot the dataset. Let's say मैंने dataset को plot किया, and so the red classes are somewhere here, and the okay, I have the blue classes as well, which are somewhere here. All right. So these are 2 classes, and we have where, okay, let me write 0 and 1 for red. Okay. So let's suppose k equals to 2 as we have set here. Okay. So k equals to 2. That means दो random कहीं पे भी हो जाएंगे. Let's suppose एक हमारा centroid होता है यहाँ पे define, and दूसरा हमारा kind of हो रहा है यहाँ पे define. Okay, so its nearest neighbors, let's suppose these will be counted as its nearest neighbors, and rest of these will be classified as these nearest neighbors. So you can see like blue वाले blue like for this centroid, of course यहाँ पे सारे blue आएंगे because only blue it has, and it has like a lot of red. So let's suppose ये red के लिए. Okay, then you can see like a lot of blue labels are coming under this radius. Okay, it's this decision boundary. So this like अगर हमारे सेंट्रॉइड जो नेबर्स हैं वो अगर हमारे ऐसे डिफाइन हुए हैं, so that is the case of you can say overfitting, because majorly एक ही class के लिए it is being identifying. So like the same example which I wanted to show you कि overfitting कैसे होती है. So this is how overfitting is generally done. Happens in the k nearest neighbor with some low value of k. Okay, so this much, like, can you all, is this understood कि how it is, how we are getting a very low accuracy even with the k value of 2. मतलब हमारी क्लासेस की भी वैल्यू सेम है एंड हमारे लेबल्स की भी वैल्यू सेम है, सॉरी हमारे के की वैल्यू भी सेम है. सो इज दिस अंडर लाइक इज दिस क्लियर कि क्यों हमारे पास 54 एक्यूरेसी आ रही है, व्हाई वी आर नॉट गेटिंग द 100 एक्यूरेसी. इफ यू हैव एनी डाउट, same for k equals to 10. Sure. If I do, let first check the accuracy. So based upon that, we will do. Okay, so we have k equals to 10. Okay, for the k equals to 10, you can see हमारी accuracy काफ़ी ज़्यादा आ रही है, that is 81, right? So I'll show, let me show you the example for the same. Let me copy the same data set, data points, copy, and let me paste it here. And let me remove all these things. Okay, so this is the original data set which we have, and let's say the k value is 10 here. Okay, what does 10 means? Like आपको ये थोड़ी confusion हो रही होगी कि labels दो हैं but 10 क्यों हम लिख रहे हैं. It does not it is not necessary कि जितने हमारे different classes हैं उतने ही हमारे k की वैल्यू होनी चाहिए. नो, इट इज़ नॉट लाइक दैट. सो मैंने 10 डिफाइन किया, राइट, एंड हमारी एक्यूरेसी आ रही है 81. सो लेट सपोज मेरे कुछ सेंट्रॉइड्स ऐसे बन रहे हैं, 1 2 3 4 5 6 7 8 9 and kind of you can say the 10th one here. All right, so for this centroid it is having, let's suppose these samples. For this centroid it is having these samples, and for this centroid it is having only like this one sample. Okay, and similarly इसके लिए भी it has only this, and for this centroid it has these samples. And इसके लिए like I'm just defining a imaginary decision boundary. The exact decision boundaries of course it will be different, like जो हमारे model के base पे आई है. We can plot it as well, but I'm not going into that plotting and all the stuff. इसमें काफ़ी time लग जाएगा. I'm just showing you how it is, like showing you the basically intuition behind it. Okay, and for this let's suppose for this we are having this decision boundary, and similarly for this one let's suppose इसके लिए एक ही है, and for this centroid we are having this one. Okay, so this is how it is, like a simple example मैंने जो आपके साथ share किया. It is underfit. How it is underfit? Okay, sorry, not, we cannot say it is underfit because हमारे यहाँ पे like मैंने accuracy के base पे I have simply plotted the centroids. Okay, because हमारी 81% accuracy, so you can see like some red labels are being identified as blue and some blue are being identified as red. Okay, and हमारे पास बहुत सारे like हमारे ये सारे like for this we are having the red, for this we are having the red, for this we are having the blue, and for this also blue. And let's suppose ये हमारे class है, and this is like हमारे ये सारे, okay, this one last I forgot it. So let's suppose ये पूरा इस area को cover कर रहा है. Okay, and we have some new test sample, something like here, which should be red. Okay, but because it is coming under this centroid and this decision boundary, so it will be considered as a blue. Okay, and hence this is leading to like this much accuracy, that 81% accuracy. Also you can say it is underfitting, uh, but not exactly underfitting, because like it depends upon the centroids कि वो कहाँ कहाँ define हो रहे हैं. All right, I'm just taking it for the two-dimensional data set, and like here we have various dimensions, like we have 3 4 5, we have 5 dimensions total. Okay, so उसके basis पे it will create various decision boundaries respectively, and For each decision boundary, it will like check the majority classes it is coming, and उसी के base पे we are getting this much accuracy. If I increase some the k value, let's suppose if I set it to 15, and now if I run it, uh, okay, so we are getting a good accuracy. Okay, 83% accuracy. Let me set it to 20. Okay, now you can see मैंने 20 के लिए I have set. Okay, like for 15 when I had for 15 you can see my accuracy is 83%, right? Almost 84, 83.7 you can say. And for 20, if I set nearest neighbors to 20, then we are getting the accuracy is 75. And if I increase it more, then okay, abhi 78 I. And let's say if I set it to something like 30, we should get a lower accuracy. Okay. Okay, it is 81, but it is lower than the, you can say, the optimal value of k. Abhi humne, like we just did a manual, we are manually finding the optimal value of k, and based on that हम कह सकते हैं कि 15 is the optimal value because we are getting a good accuracy. But जैसे मैं 15 से increase करके 20 पे जाता हूँ, you can see accuracy is decreased to 75. Okay. Why how 75? Like मैं यहाँ पे 20 तो obviously I can't plot. But if I simply take the, okay, not here, let me, yeah, define it here. If I simply like अगर मैंने अगर we have 20 centroids, right? So बहुत सारे centroids क्या है, like accuracy is 75. It means our model is underfitting. We can only evaluate higher value के, okay, sorry for the confusion. जब भी कोई higher value होगी k की, it may lead to underfit, but we can only check it by evaluating the model. Like अगर हमारी accuracy decrease हो रही है, then we can say our model is underfitting for that respective k value. And how it is underfitting, let's suppose बहुत सारे centroids ना यहाँ पे बन गए, okay, and it is taking like each sample like this, okay. So हर एक sample के लिए ऐसा ये centroid बन गए, and let's suppose for this respective centroid it is taking these like this and this, okay. So this kind of situation causes our model to the underfitting, okay. So इसलिए like we can say it is as a, like it is being, our model is being underfit, not overfit. So जनरली लाइक थोड़ा सा डिफरेंट होता है कि हायर वैल्यू में ओवरफिट करता है, बट दैट इज अपॉन, we can't say like just by looking at the k values and the labels. We have to check the like the accuracy mainly, or the any evaluation metric to check whether that respective model is underfit or overfit, okay. And for finding the optimal value, okay, मैं एक और चीज if I do, okay, by default the metric was this min course fee. If I set the metric as Euclidean, um, Euclidean, and now if I run it, okay, I am getting almost the same accuracy. So बहुत सारे metrics हैं, metrics पे भी depend करता है the accuracy, okay. Sorry, we have for the man, okay, let's check the cosine only, that is more familiar. So okay, now you can see मैंने cosine metric लिया, so we are getting the 72, almost 73% accuracy, right? But अगर मैं Euclidean metric लेता हूँ, if I set the metric as Euclidean, you can see our accuracy is 84, and by default if I choose the default metric, that will also give, that is also giving me the same metric, because based upon that metric formula the distance is being computed. And कई बारी क्या होगा, like okay, मैंने यहाँ पे कोसाइन लिया था, so with this cosine I am getting 73% accuracy here. If I set it value to like some 10, देन मेरी ओके काफ़ी ज़्यादा डिक्रीज हो रही है. इफ आई सेट इट टू या ओके 15 के लिए इफ वी कंसिडर एंड कोसाइन यू कैन सी लाइक मेरा मॉडल का स्कोर आ रहा है 73. सो व्हाट कैन वी से लाइक आवर मॉडल इज बीइंग अंडर फिटेड और ओवर फिटिंग और इट इज ऑप्टिमल. व्हाट कैन वी से? व्हाट डू यू थिंक? एनीबडी जो भी आपके गेसेस हैं यू कैन राइट एनीथिंग और यू कैन इनफैक्ट स्पीक आल्सो. ओके मैंने मैट्रिक कोसाइन लिया. 15 के नियरेस्ट नेबर्स हैं. फॉर दिस मेट्रिक आई एम गेटिंग 73% एक्यूरेसी. अगर मैं डिफ़ॉल्ट मेट्रिक की वैल्यू लेता हूँ देन आई एम गेटिंग 83% एक्यूरेसी. सो व्हाट कैन यू से लाइक बाय चेकिंग द पैरामीटर्स एंड द स्कोर लाइक is our model being underfitted or overfitted? Anybody? Yes, it is being underfitted. क्योंकि वही लाइक नेबर्स तो ओके सेंट्रोइड्स हमारे डिफाइन हो रहे हैं बट फॉर दैट रिस्पेक्टिव सेंट्रोइड लाइक टू कंप्यूट इट्स नियरेस्ट नेबर्स दैट द नियरेस्ट सैम्पल्स we are using the cosine metric and maybe वो cosine metric it may be like I don't know the exact formula. I'm just taking a guess कि let's suppose मेरा centroid यहाँ पे है and with the Euclidean distance it is having this kind of decision boundary. All right. And maybe अगर मैं cosine वाला यूज करता हूँ metric so I may get like this kind of decision boundary for that respective centroid and it is having the blue. Okay, so this is where underfitting is happening. Okay, so that's why I said two main things are here, the metric and the k value, that is the nearest neighbors. All right, so is this clear to you all, like how it is mainly working, the intuition mainly, like when it underfits, when it overfits. Mainly question इसी के ऊपर ऐसे ही आएंगे कि underfit कब कर रहा है, like for the higher value of k if we are getting this much accuracy or for some higher value. uh, कुछ भी और सैम्पल्स एग्जांपल्स आ सकते हैं. आई एम नॉट श्योर अबाउट दैट बट यही आएंगे मेनली क्वेश्चंस कि लाइक अंडरफिट कब कर रहे हैं एंड ओवरफिट कब कर रहे हैं. So is this much clear, like when it is underfitting or when it is overfitting?
Yeah, from
Yes.
here underfit, if value k is more, then it is underfit. And generally, if value is k is high,
Mm-hmm.
then it is overfit.
Okay.
But here, and the value
Uh,
of the and second, it's depend on accuracy. It is underfit or overfit.
see, mainly it depends upon the parameters and parameters के base पे ही we evaluate the model, right? And based upon the evaluation score we check whether our model is being underfitted or overfitting. The same thing happens in cross validation, right? If we are getting a higher accuracy or higher mean squared error, that means our model is probably like overfitting. If we are getting a lower accuracy, that means our model is being underfitted, right? Same concept lies here, just that k की value थोड़ी opposite में है, like you can say, because that is kind of taking the different values. अभी हम इन centroids को manually भी define कर सकते हैं by using the weights parameter. All right, so this is the weights parameter. By default it is uniform. Okay, so we have distance as well and other we can also like set a user defined function जिसमें हम different weights value हर एक like k value के लिए we can set. Okay, so let me give you one more example how it is being underfitted. If I okay, if I take this data set only, let me copy it. Okay, yes, मैं इसी का ही okay. This case is of overfitting, right? ये केस आपको समझ आ रहा है, like we are getting 54 accuracy, k is equals to 2. It is identifying a lot of samples as red and some of them as blue. Okay, so and a lot of blue samples as well as red. So this is the case of overfitting, you can say. Is this understood, Amit? ये वाला clear है
Yeah,
आपको?
understood.
Okay,
हाँ.
same if I take the same one here and let me remove these things. So for higher value of k, let's take k equals 8. Let's suppose k equals to 8 pe, we are getting an accuracy of 60%. And at k equals to 5, we are having a optimal value. How? Let me show you the case. Let's suppose मेरा एक यहाँ पे ऐसा defined है, something like these. Okay. So, okay, how many I have? 1, 2, 3, 4, 5, 6, 7, 8. So all 8 are defined. All right. Now, if you see, for this one, let's consider this is its decision boundary. All right. Like this is from where it is classifying it as blue, right? Then for this centroid, it is having let's suppose these samples. Okay. Let's suppose these many samples, like we can say like this, or let's suppose यही मैं लेता हूँ सिर्फ इतने. And then for this I am having, let's say, some kind of this decision boundary, like it is covering all these samples. Okay. And for this I am having this one, and for this as well this, and hence so forth. And for this one it is taking the all the rest of the samples from here to this, and we have the last decision boundary, something like this. Okay. So here you can see like these 4 blue samples are being considered as a red because it is coming, we have majority red samples here. And उसी के बेस पे like it is being considered as underfit क्योंकि बहुत सारे जो blue samples होने चाहिए that are being considered as a red sample. Okay. If I define some blue samples here also, so the same thing is like happening कि बहुत सारे samples जो है misclassify हो रहे हैं because of some higher value of k. And not just that कि higher value of k, it is also like हमारे जो ये defined है these centroids, these centroids for which like जो neighbors identify करेंगे, these are like more closer to, you can say, blue here. Okay. एंड लेट्स सपोज मैं मेरे जो है कुछ ऐसे भी नेबर्स बन रहे हैं. ऑल राइट. एंड समथिंग लाइक दीज, एंड समथिंग लाइक दीज. ओके. So this is how underfitting is happening. I'm just giving you a visual example ki how it is doing the underfitting, how basically underfitting is happening. And rest, like main two things pe it depends, like on the metric as well as the main thing is the k value. Rest weight, on weights also it depends, like if I set some weights in a better manner, then हमारे जो है better predictions हो सकते हैं. Doesn't mean कि like अगर हमारी k की value भी ज़्यादा है and we have some different unusual metric, if we set the values कि जहाँ पे centroids होंगे, initial centroids होंगे, defined होंगे, अगर वो मैं वैल्यू कुछ अच्छी वैल्यू सेट करता हूँ कि वी हैव लाइक गुड अमाउंट ऑफ सैम्पल्स, सो उससे जो है वी वोंट गेट like our model won't be underfit. So that is the case here. Okay. Is it understood?
Okay. Okay. Thank you.
So this is like mainly about the k nearest neighbors. Now let's move on to the SVM, support vector machines. Okay. Anybody knows what SVM is? हमने बहुत ज़्यादा किए, like in MLT. I think we had 2 weeks of SVM only. Anybody, like anything, if you know anything about SVM? Anyone? All right. So see, SVM is generally like it is for classification only, but it is like generally you can say, okay, support vector machine. Let me take by the exam name directly. Okay. So support vector machine, how, if I let me plot my data set here, and I'll take the 2 samples. Okay, 2 binary samples, something. Let me increase points. So something like these, and then some blue as well. Okay, and now if I draw a line like this, okay, so this is a line, and now let me draw one more line as well, and let me set it as a dashed line. Same line I'll draw, okay, here. Let's say something like this, and just like to cover up all the concepts under this support vector machine. Generally this is parallel, so we can say uh, um, okay, so let me take, okay, let's consider this as a line as of now. Okay, so this is like a basic, I'm building the intuition behind support vector machine. Okay, what is a support vector machine? It is mainly like to classify, mainly we use the support vector machine for like binary classifications problem. Okay, what they do is and उसका एक main criteria क्या होना चाहिए? Our data should be like linearly separable. Okay, linearly separable means okay, linearly separable means like एक line के through we can separate the data set. Okay, so if you can consider this as the main line, okay, and based upon this line our both classes are being separated, right? Is this diagram understood? Like, can you all clearly understand like how this line is differentiating red and blue?
Yeah, right, right.
Okay, so this is just a basic diagram, you can say, for the support vector machine. I have like two features, x1, x2, and this is kind of the, it's you can say the main model line. Okay, and based upon that model line we had some equation. मुझे अब वो equation का exact, like I don't remember the exact equation, but if any new sample, let's suppose मेरा एक new sample है which is somewhere here. Okay, let's consider somewhere here like this. Okay, if the sample is coming in this direction, then it will be considered as a red class. Okay, considered under as a red class. If the sample is coming something like somewhere here, so it will be considered like ये blue side की तरफ के classes के बाहर है, right? So it will be considered that it is of a blue class. All right, so this is like the main thing, okay, how these classes are being identified. The main thing is that, and like it first simply create a simple, you can say, a line, and how that line is being made, that is the mathematics behind it. I don't remember the exact equation, but the intuition is it takes some vectors and computes the basically distance, and it tries to maximize the distance. How? Like to make the like classifications better, अगर मैं यहाँ से ऐसे distance इन सबका compute करूँ, and based upon that labels, let's suppose 0 के I have the 1 as red and 0 के लिए blue. Okay, so उसके base पे it is like it will compute the distance and it will create a margin. This, okay, I should zoom out. This okay, अभी भी बहुत ज़्यादा है. This distance is, can I like, yes, this distance is being considered as a margin. Okay, so the main thing we have to do is in support vector machine is to maximize the margin, that margin helps us to create a better line for the model. And वो margin कैसे define होता है? It defined based upon the support vectors which we have. Okay, so here you can see this dashed line is like intercepting this blue label. Okay, so this is that blue label, whatever its values has, like the features it has, this is being considered as a support vector. Okay, same for these two as well. So these are the support vectors. Based upon the support vectors, we define the margins, and based upon the margins, एक linearly separable line define होती है, and that line is used to separate the labels, like whether they are for the uh, blue class or for the red class. Okay, so this is like the basic intuition behind the support vector machine, and the main thing is the data should be linearly separable. Okay, so ये थोड़ा सा एक टास्क होता है, but we have some other things as well, the kernel SVM and all. I think in MLT week 7 में था हमारे पास, या week 9 में kernel SVM, and हमने काफ़ी कुछ पढ़ा था, right? That I will also show you, but mainly like, okay, these are the models, these are the margins, and these things are support vectors. Okay, so इतना clear है सबको कि like what are support vectors, what is margin, and how are this perfect line is being made. Okay, if it is not clear you can speak up, मैं दोबारा समझा दूंगा. All right, so this is like the main things, and this is just for the linearly separable data set. Okay, and based upon these support vectors, a margin is being defined, and हमें वो margin को ना maximize करना होता है, like जितना भी बड़ा margin होगा, and that margin like should not cross these labels. If it is crossing, then those labels are considered as, you can say, the null labels. All right, so based upon that labels, it defines a margin, and based upon that margin, parallel line is being made. That is the our model, which is, you can say, the SVM model, and वो model फिर kind of new test sample को classify करता है whether it belongs to the whether it belongs to the red class or blue class. Okay, so this is the general intuition, you can say. इसमें भी कुछ ज़्यादा नहीं है. The main thing is under the kernel SVM. What is a kernel SVM? Let's suppose ये तो हमारा हो गया linearly separable data set के लिए. All right, let's suppose our data is something like this: x1, x2, and if I'm taking a very general example. Okay, okay, can we say this data is linearly separable? uh, just like can we say
No,
this? All right, everybody
no.
agrees this data is not linearly separable. Like हम एक line के base पे we cannot separate the, okay sorry बहुत मोटी line हो गई, just like on a base, on the like basis of a single line, we cannot separate the data, right? This is not linearly separable. So what we do is, here like comes the concept of kernel SVM. Okay, what is kernel SVM? Let's suppose it basically do some transformations on the features, and it makes the data as a linearly separable. Okay, so how, let's suppose ये दोनों features के base पे I have created another feature which is x1, x2. All right, and that if we check in the like 3D graph. Okay, okay बहुत ज़्यादा slant lines हो गई, like this. All right, so these are the samples, and if I like, this will be the x1, x2, and it is x1 x2. Okay, now if I plot it like okay, the red value, yeah, I have to increase the stroke value. So red are being coming here, and blue जो samples हैं those are coming here. Okay, so okay, not it is not kind of rounding them, yeah, like this. Okay, okay, how should I like, okay, basically like itne se can you all, okay, now can you say this data is linearly separable, the right graph, can we say this data is linearly separable now? Just yes or no, like what do you think? If I simply create a
Yes.
line, yes, okay, let me remove some data points from here, जिससे एक perfect line create हो जाए, just to give you the example. So if we create a single, okay, again it's a very big line. If I create a single line like this, not, yeah, uh, like this, all right, something like this, you can, let me take the line, I think that would be better. This is the line, all right, and let me make it, this is much better. So this is the line, right? Now we can say our data is linearly separable, and this is what kernel SVM do. हमने बहुत सारा MLT में पढ़ा होगा, मुझे तो क्लियर नहीं हुआ था, आई डोंट नो आप लोगों को कर्नल SVM like in actual, like not in the equation manner but in visually how it is working, कितनों को clear हुआ? But the basic thing is what kernel SVM do is it takes the feature, and if the data is not linearly separable, it basically map those features, it do a transformation. Okay, हमने linear transformations पढ़ी थी maths 2 में, right? And it takes the data and it do the mapping, basically does the linear transformation and convert the data into a linearly separable data set. Okay, so this is like you can say a 3D plot, and we have a new feature, you can say, based upon these two features x1 and x2, and that is giving us like the data as in linearly separable. And in 3D we call a line as a plane, right? We don't have a single line in 3D, we have a plane, right? So this line, this is not a actually like, this is not a line exactly, this is a plane, all right? So plane is like you can say a whole span of vectors are coming under this plane, that is like a line is a single line, we can say. In 2D we call this as a line, but in 3D we call it as a plane because it covers a span of vectors. Okay, so this is just a simple difference, and the same thing, uh, the same mathematics things kernel SVM uses, and it creates the data set as a linearly separable in different dimensions, or by creating the different transformations of the data set. Okay, so this is just like after creating the after basically creating the data as a linearly separable, it creates the its soft margin and hard margins. Okay, not okay, we won't go into that soft margin and hard margin things. It simply create the margins. Okay, let's suppose यहाँ पे एक बहुत ही छोटा सा एक margin create हो रहा है, something like this. All right, this is one margin, and if I create one more, so this is something like this. Okay, so this is how an SVM is being done in a non-linearly separable data set. That is the main thing जो मैं clear करना चाहता था. Basically SVM तो हमने बहुत अच्छे से पढ़ लिया था MLT में, आप जितना समझ आया जितना नहीं, but yes, most of the things आपको इसको देख के समझ आ रही होंगी. Now like अभी थोड़ा सा SVM clear हो रहा है आपको, like how it basically identifies works in the non-linear data set. Is this understood, guys? Yeah, should I like take some another example? you can like speak up or react anything so that we can move ahead.
Paraphrase how margins are formed,
Sorry.
how margins are developed here.
Okay, margins are developed. Okay, there is some, I don't remember the exact equation. Based upon the support vectors, okay, it chooses some vectors, and it basically tends to create like the maximum difference between those vectors and the line which we have. Okay, and for let's suppose मेरे पास एक ये vector आया, something like here. Okay, which basically corresponding to all the, which is basically representing all the red samples. Okay, so this is the closest vector we can say to this line, right? And based upon this vector only, we a line is being drawn and which is being considered as a margin. Okay, and that margin is being helping our model to classify whether it should come under that respective red class or the blue class. Okay, so this is how margins are being formed. Mathematically, like मुझे exact equation नहीं पता, so I won't go into that one. But the main thing is I want to clear the intuition, so इतना I hope आपको clear हो गया होगा.
Okay.
For the mathematics, of course, MLT lectures are there. You can go and watch them. Okay, so this much is clear to you all. I know थोड़ा like वेग हो रहा होगा, but that's okay. अगर बस आपको like main underlying concept थोड़े पता होना चाहिए. Like in SVM we need support vectors. We have a concept called margin. In K nearest neighbors we have a concept called the distance matrix, the how neighbors are being defined. Okay, itna, just that much you should know. Similarly, for the logistic regression, like I had covered a lot in the previous session regarding logistic regression, but उतना deep में जाने की ज़रूरत नहीं. You just need to know the how log loss function is working, how logistic regression and how sigmoid function is being defined, the curve, and how threshold and decision boundaries being made. बस उतना आपको पता होना चाहिए. Rest the mathematical equations that can be understood if you have the visual explanation, right? Abhi, like I have shown you this much kernel SVM, how kernel SVM works in a visual manner. Now, if you check the formula and if you read how kernel SVM works mathematically, so आपको जो है वो पढ़ के और आप ये विजुअलाइजेशन सामने रखोगे, देन आपको क्लियर हो जाएगा. ओके, how it is doing the transformations and creating the data is linearly separable and doing the classifications. Okay, so this is for the SVM, and in SVM we have like various things. Okay, in SVM एक तो हमारा like we have like linear SVM, that is for linearly separable data set, and we have kernel SVM as well. Like different हमारे पास और भी techniques होती हैं, RBF, something like that, but those are obviously RBF, and those are for making when we have a non-linearly separable data set. One of them is kernel, like kernel SVM, and similarly we have other techniques as well like RPF and all. So जो पैरामीटर्स आपने देखे होंगे इन द GA like RBF and other things, so वो वही है, just to classify our samples perfectly. Okay, and okay, yes, one more thing, sorry, this margin, like we have to mainly there is some optimization we have to do in SVM, and that optimization is we have to create a best line, you can say best linearly separable line, which should clearly can separate the data. Okay, let's suppose if I take this, okay, now let me select it. Yes, now if I copy it, let's suppose this is the data set, and if I remove some of these things, and margin model. Okay, not that one. Yes, so this is enough. So we have, let's suppose, this data set. Okay, and एक normal start हुई, we start from a very simple line, like this. If I made something like that, okay, very simple line. Here if we form the margins, तो हमारे पास कुछ ऐसे margins आएंगे, something like that. Okay, and one more margin here, which will be somewhere here. Okay, so these are the margins which are formed, and what we have to do is, the optimization thing is, like, we have to maximize the distance between this line. Okay, this line and the margin. Okay, this model line and the margin, we have to maximize the distance, and that distance we can maximize like via a parameter. आपने जो parameter एक देखा होगा, we had a parameter called c, right, in the model when you are defining like c equals to 10, c equals to 3, and a lot of people were asking on this course, like, how it is affecting the mainly how it is affecting the model and how it works mainly. So okay, let's suppose मैंने एक ये बहुत ही simple सी line बनाई, and we can, if you see, the best fit line, which you can say, best fit line is like this, right? So we can find the distance between this line and other vectors, and we can check कि हम और ज़्यादा हम इस margin को expand कर सकते हैं या नहीं. Okay, and basically that distance, which is known as c, and that we can expand by how much, that is the main hyperparameter which we have. Okay, so that we have to compute, and if I copy this one again, and let me remove these things. Yeah, now let's suppose हमने जो है यहाँ पे एक basic start किया from this line, and then we have found कि we can expand our margin something, we can create our line something like this. If I draw it here, something like this, and we can expand our margin, right? So हमने जो है, we have computed the distance and all the other things, and then we found out that we can expand our margin by creating some line like this. Okay, and that will simply help us, like, in the model basically. जितना हमारा डेटा मोर, हमारा जो लाइंस डेटा है मोर लीनियरली सेपरेबल जितना ज़्यादा है, उतना हमारा इजीली, लाइक, छोटे बड़े मार्जिन से काम हो जाएगा. लाइक बाय डिफॉल्ट द वैल्यू ऑफ, like, the distance which is between the line and this margin is known as c, and by default the c is very high, like you can say, and that higher value of c basically won't be able to classify the data as much, क्योंकि हमारा margin बहुत बड़ा होता है, and we tend to, like, have a good margin that will lead to the very less training error. यहाँ पे मैंने बहुत ही, like, simple सा data लिया जो बहुत easily linearly separable है. Let's suppose मेरे पास कुछ ऐसे samples भी आते हैं, something like these. Okay, तो थोड़ा सा these can cause as a, like, this is considered as a error, right, this data point. So that can be handled via c parameter, that how big our margin should be or how small our margin should be, and बाकी तो SVM खुद ही compute करता है, like, by checking the differences between the difference of the distance between the samples and the which model line which we have. Okay, so this is just a basic overview of SVM. इसमें और कुछ ज़्यादा है नहीं. The main thing was to, like, clear up the understanding of kernel SVM, like how it separates the non-linear data set. Majorly हम लोग कॉपी पेस्ट ही कर रहे होंगे डेटा, लाइक कोड. इनफैक्ट अगर हम लिख भी रहे होंगे अंडरलाइंग अगर कंसेप्ट्स क्लियर नहीं होंगे, आई होप अभी थोड़े से आपको कंसेप्ट्स क्लियर होंगे कि हाउ इट इज़ डूइंग ऑल द स्टफ. So is it understood?
पर हम जो हमने यहाँ पे सी यूज किया और एक ठीक है ये सी जो मशीन लर्निंग टेक्निक में हमने पढ़ा है. इसके अलावा एक सी हम यूज करते हैं रिग्रेशन में लिखते हैं सी इक्वल टू 0.5. ये दोनों अलग अलग है उसी सी की, ये
That
सेम
is
सी
the
है.
logistic regression. वो C होता, वो is also a regularization parameter. वो
या
वो अलग, वो logistic regression में, ये SVM में है. Both are different. Don't combine them. ठीक है?
वो रेगुलराइजेशन के लिए है ना.
Right.
ओके.
Don't combine them, क्योंकि हमारे पास बहुत सारी बहुत सारे मॉडल्स में ये होगा, we get the alpha parameter, right? In alpha, maybe in linear regression we have the alpha, right? Maybe some in other parameter, sorry, in some machine learning models we may have the some alpha value, like some alpha parameter. So don't mix them, both works in a different way. That depends upon the model. Those are just names. Okay, C is just a name, you can say. So that is it. And बाकी hard margin and soft margin पे मैं ज़्यादा जा नहीं रहा, क्योंकि थोड़ा बहुत आई नो, बट आई डोंट वांट कि ऐसे कंफ्यूजन क्रिएट हो, रादर देन दैट कि आई शुड नॉट एक्सप्लेन दैट पार्ट. Okay, so this much is clear, like how kernel SVM is made and how do we do the optimization. Okay, you can even give a thumbs up if it is clear. Okay, so बाकी तो like regarding the code तो आप सबको पता ही होगा if you have done the week 8 week 8 GA. So we have a class module called SVM, and in the SVM we have various SVM, like linear SVC. Linear SVC is basically the SVM in a linear format. Then a simple SVC, SVC as well. Okay. Now if I simply let me create a model called linear SVC, and here I'll do model.fit extend ytrain. The main thing is same in all the model things. Okay, so I'm getting a fail to converge, increase the number of iterations. So let me increase the number of iterations here. Max iter, let's say I'm setting it to 1 lakh. All right, obviously it will take time. थोड़ा छोटा कर दूं, that would be much better. Okay, still I'm getting failed to converge, doesn't matter. Let's ignore this one, the warning. Okay, then if I create a model 2 as well, SVC, and model 2 dot fit ytrain. सो लाइक आप इससे थोड़ा सा अंदाज़ा लगा सकते हो कि हमारा लीनियर SVM अगर हमने यूज़ किया, सो आवर मॉडल इज़ नॉट कन्वर्जिंग. बेसिकली it is not able to find a, it is not able to linearly separate the data set. Okay, by that warning you can identify. And now if I check the score as well, so model dot score x valid, y valid, and so we are getting 75% accuracy. If I do model 2 dot score, you can see we are getting a better accuracy of 81. And in the SVC we have a kernel parameter. Okay, and if I set kernel equals to linear, it becomes the same model as this one. Okay, now if I run it, you can see accuracy बहुत decrease हो गई है. Why it is 70, why it is not 75? क्योंकि बहुत सारे और भी parameters होते हैं. We have like, if I set all these parameters same as it is here, then we will get almost the same accuracy. Okay, so if we use this code, this code is same as this code. Okay, there is not much difference. So अगर आपको linear SVM यूज़ करना है, if you know your data is linearly separated in all the features then you can simply use the SVM model. Why SVM model? It is very easy to train. Like, why should we use SVM? Okay, इसके थोड़े से pros हैं that are like it is very easy to train and on mainly on the linearly separable data set and easy to train and hence easy to interpret as well. Ki like it is creating a model and a margin and we have some support vectors. Based on that support vectors it is classifying different class samples. Okay, so it is like and very fast as well. So linear SVM are very fast as well, like while training. So that is like you can use the not very fast in different kernels. Like हमारे पास बहुत सारे kernel parameters हैं. If I show you, अगर हम wrong kernel use करते हैं, let's suppose अगर हमारा data linearly separable नहीं है and अगर हम कोई गलत kernel use करते हैं, then we may get like wrong values. Okay, so you can see kernel is linear poly and okay, that poly is the same kernel as this one. Okay, I have created a polynomial feature here x1 x2, okay, for that data set. So this is, you can say, this is the poly kernel. All right, so we have various kernel parameters and you can set different parameters based upon the data. And would आप कैसे identify करोगे how your data is linearly separable? Simple answer is EDA. Okay, do the EDA, check your data distribution and then to use the appropriate model. After like all these sessions, maybe like in OPP2 or maybe after OPP2, I'll take one extra session and उसमें I will show you like real world में how should you go with the data set and all the things. Okay, so that like don't use any logistic regression tree models based upon like just randomly कि आज मैं ट्री बेस्ड मॉडल यूज़ करता हूँ, कल मैं SVM कर लूँगा, फिर लॉजिस्टिक रिग्रेशन कर लूँगा. डोंट डू लाइक दैट. आई शेयर सम टिप्स. ओके, कि कब आपको कौन सा मॉडल यूज़ करना चाहिए बेस्ड अपॉन द ED एंड ऑल द स्टफ, सो जिससे आपको बेटर अंडरस्टैंडिंग हो एंड बेटर मॉडल मिल पाए. इट इज़ लाइक मॉडल्स हमारे पास बहुत लिमिटेड है बट सेम वही लाइक सेम मॉडल्स हम भी यूज़ कर रहे हैं, सेम मॉडल्स बाकी कंपनीज भी यूज़ कर रही है लाइक ओपन AI एंड अदर कंपनीज. बट उनके लाइक उनके जो AIs बन रहे हैं, दे आर वेरी एफिशिएंट. वाई? because they know the understanding behind the models and they are using the best model with the best parameters. So of course data is the main thing, but apart from data, modeling का भी like एक काफ़ी होता है, important role होता है कि which model you are using and do you know like how it is affecting the data, how it is learning the data. Okay, so this is like about these two models, KNN and SVM. Now the third one, it is naive bias. बहुत ही बेसिक सा, बहुत ही easy you can say ML model है, ML algorithm, naive bias. Okay, anybody knows what is naive bias? I think हमने week 7, it is in week 7, right? If you have any like idea about naive bias, you can say कुछ भी, anything.
Conditional probability.
Yes, it uses the concept of conditional probability, which is mainly the Bayes theorem, right? So
Yes.
from that, only from that Bayes theorem, the concept of naive bias comes. Okay, so it basically like uses the concept of probability, conditional probability, that is the Bayes theorem, a Bayes theorem you can say. Okay, which is like P of A given B. Okay, I'm writing in very Bayes theorem, which is defined something like this: probability of some event A given that B has occurred is something given B has occurred A into probability of A. अगर I think I'm writing Let me check once. Bayes theorem. Yeah, it is almost right. Like this. ओके बेस थ्योरम तो आप सबको लाइक क्लियर ही होगी. मैं ज़्यादा कुछ मतलब ये तो यू कैन से इनफैक्ट स्टैट्स 2 में स्टार्टिंग में ही हमें बेस थ्योरम का पता चल गया था. Like based on the concept of Bayes theorem, it uses like all the features, like जितने भी हमारे features हैं, it finds the probability like that A is replaced by okay, मैं इसकी ना ML की notations में if we write, it is something like this. Given all the features x1 to xn, okay, it finds the value of y. Something like this. Yeah. Probability of x1 till x1 given some value of y. I am just replacing the a and b with the x and y so that हमें थोड़ा सा आइडिया लग जाए. Probability of x1 till xn. Okay, so this is like the main equation behind the naive Bayes. Okay, हर एक feature की it finds the probability and then it combines the probability basically. uh, Basically it combines the probability, multiply them, and then it uses the Bayes theorem on the target label y. Okay, and it simply like compute what value should we get for each label. अगर मैं like main intuition तो इसमें यही है. Graphically I don't know much like how can I represent it, but the main thing is this only, the Bayes theorem. It finds like probability के base पे कि which value should we have. नेव बायस का मुझे ज़्यादा नहीं like कुछ आइडिया, थोड़ा बहुत जितना आइडिया like उतना मैं आपको बता रहा हूँ. एंड बस ये है like in the scikit-learn we have various naive Bayes, like various forms of naive Bayes theorem. Okay, like we have Bernoulli, we have multimonial, we have categorical naive Bayes as well. I don't remember the exact name. Categorical.
Gaussian.
Yeah, Gaussian. We have the Gaussian as well.
And complement.
Yeah, right. That complement is the categorical itself, I think. No. Sorry, not the categorical. Complement. So ये तो मेनली नेम से ही पता चल रहा होगा. ओके, मैं आप इसके बस थोड़े से ना ये बता देता हूँ कि लाइक व्हेन टू यूज़ विच वन और व्हेन टू यूज़ विच वन. लाइक बर्नौली तो आप सबको पता ही होगा. आई डोंट थिंक मुझे बताना चाहिए. कोई भी आप बता दो लाइक इफ एनीबडी वांट्स टू से like what is Bernoulli, like when do we say when we have some like events and their respective uh, outcomes like with the probability, when we हम बर्नौली कब कहते हैं like based upon the data.
Boolean.
Yeah, Boolean values mainly when we have two outcomes, okay, either 0 or 1, like heads or tail. Or similarly for this data set, we have only two outcomes, either survived or not survived, right? So then we use the Bernoulli one. And multimonial when we have more than one classes, like 1 2 3 4 5 6 and so on and so forth. Then we use okay, before the complement, let me tell you about the Gaussian we use when we have a regression problem. Okay, Bernoulli we use Bernoulli and multimonial we use when we have the classification problem. And the complement is mainly, it is being used when we have the imbalanced data set. Okay, imbalanced and in the classification only, क्योंकि classification में data imbalanced होगा mainly. तो so like imbalanced data set तो I don't think मुझे ज़्यादा बताना चाहिए. Last session में we have covered it a lot. It's like when we have like two values, let's suppose 0 and 1, and out of 1000 samples only let's say 900 are zeros and only 100 are 1 values, so that we can say our data is imbalanced. That target label, okay, when we have our target label, imbalanced target label, then we use the complement one. And when we only have the normal proportionate values, then we simply use normal Bernoulli one. If I check my, like, this is my Y train, if I simply do value counts, you can see okay, my data is somewhat imbalanced, not exactly, we can say. If I check the proportion normalized to, so it is like 64% of the data is of 1 and rest 36 data is of 0 class. So we can say this data is imbalanced, right? Our current one. So if I use the Bernoulli one, let me use both of them. From sklearn dot naive bias import Bernoulli NB. Okay, yeah, Bernoulli NB, and let me import the other one as well, which is complement NB. So let's create two models, Bernoulli NB, and here I'll simply model dot fit exchange y train, and I'll check the score as well directly, x valid y valid. Alright, so I'm getting 83% accuracy. Let me just copy it, and rather I'll use complement. Maybe we may get like, okay, we're getting a very bad accuracy in complement NB. Okay, mainly thoda sa imbalanced है, like the proportion is somewhat imbalanced, not exactly, but agar, yeah, it is imbalanced, I agree, but thoda sa imbalanced है. If we have a very imbalanced data set, like 90:10 का ratio or 80:20 का, yeah, in fact उससे भी ज़्यादा, then using complement is much better. Okay, so this is like all about the naive bias. Naive bias में ज़्यादा कुछ खास है नहीं, it is just the underlying bias theorem which we have, and then we have its like some different variations of naive bias: Bernoulli multimodal, complement and Gaussian. So that is it. इसमें किसी को कोई confusion in the naive bias? All right, so I think that's it for the session. आज ज़्यादा कुछ नहीं था, mainly algorithms थे, but intuition थी behind those algorithms, and these algorithms are easy enough, so that's why it won't take like ज़्यादा time हमें लगा नहीं. So that is it, and rest, like as I said, like I have created a classification evaluation metrics cheat sheet, okay, that you can check it out. So okay, github.com my resources, so yeah, this is like the cheat sheet which I have created. इसमें I have shown the example, like step by step, these 3 steps, like how you create a confusion matrix, and other formulas as well, like what is precision and how it is being calculated, and recall and F1 score, and mainly ये भी कि like what are false positives and what are false negatives. I have added this table so that सब clear हो जाए. I hope ये आपको आज का सेशन हेल्पफुल लगा होगा. यस, उसका मैं अभी जस्ट 1 मिनट में बताता हूँ, एंड बाकी चीट शीट भी लाइक आप लोगों को हेल्प करेगी, लाइक फॉर द इनफैक्ट
Could you please
इवैल्यूएशन एंड बेसिक
provide that link?
sure. This is the link. You can download the cheat sheet from here, like the dark one or the light one, both I have added. Okay, I've also
Okay.
shared them in the groups as well. So yeah, that's it about the session, and as I said, I will upload the recording of the session in my YouTube channel. uh, this is my YouTube channel, you can subscribe to it, and I will share the recording in that. Okay, and okay, so